welcome everyone here and viewing later. So this talk is called Beyond the Download Count, Understanding Usage of Your Public Containers. My name is Avi Press. I'm the founder and CEO of a company called Scarf, which is a company that's concerned with basically this very topic of how we can get maintainers better data about how their software is getting used in the wild. So we'll talk today about kind of the state of container registries today and what data they can provide you as a container publisher. We'll talk about just like what a pull actually means and like how it works under the hood. Talk about all the data that's actually in those pulls and then how you can actually go about getting that data. And so some quick notes. These slides, while they look very minimal. That's because they are generated from an org mode document, which is available on GitHub, as well as these slides. So feel free to click through the link and just read through the source if that's your preferred way to consume this. And then I guess we got in a particularly small group here right now, so definitely feel free to jump in with questions as we go. All right, so kind of the high level thing here, the state of the world today is that the stats that you get from container registries are incredibly limited. Docker Hub is nice enough to give you the total number of times your container has ever been pulled forever, and that's it. Some of the other container registries give you a little bit more. So like GitHub Container Registry will give you like total pulls for the whole repo and then also for each tag, which is very useful. But like if you're looking at latest, like, well, what does that mean? Which latest did they pull? You don't really know. Key.io kind of gives a similar amount of data. ECR goes a little bit further and even will give you kind of the time series of that pull per repository that you can kind of visualize in things like CloudWatch and those kinds of tools in AWS. But generally, the state of the scene here is that you get very little data, and it's only at this very high granularity. Like tag is about as granular as we're going to get. But we might want to know quite a bit more than that. And so, like on the metric side, if you got 10 pulls today, like did that come from 10 people or did that come from one person? Those are very different kinds of things, and that number totally includes that information. You might want to know, like, what hosts are people on? Is this getting downloaded on Mac, on Linux? Like, where are these containers getting run? The container runtime, the country that the pull came from, the architecture of the machine. Maybe you want to know what companies are downloading. And then even further from that, you might want to ask the registry, like, are these, like, I'm getting these number of downloads, but how many times is the container actually getting invoked? A detail that some might not know is if you start a container that's on your local machine, that's still going to ping the registry to check if it's up to date for that tag, but that's not exposed to you, the maintainer. So this is just kind of a sample of the kind of metrics that we might be interested in depending on your use case, but even more than that, you might want to get a little bit more granular about those metrics. Like how many downloads did you get yesterday or last week or last month or like every Tuesday? Like there's a variety of different kinds of queries you might want to run against that download data, but just getting that total number in most cases is not particularly useful. And so let's kind of back up and talk about like what a pull is. Like if we're going to talk about what we're trying to count, let's make sure we understand what it is that we're actually counting. And so some key terms that might be reviewed for some of us, but we'll get pretty specific here. So one of them is a manifest. For any image, there's an associated manifest. That's basically, it's a JSON file. And it provides all the details about all the different layers and the little pieces that make up your container. It has some metadata about the architecture and the operating system, and any other associated metadata the registry may have needed to throw in there for a variety of reasons. And then we also have what's called a blob. And a blob is basically like it's just data. It's a blob. It's data that comprises the layers of your image, and those, in practice, could be stored in a variety of different places. And the manifest will tell you where to go get those blobs. And so, to give a specific example here, or this is kind of like a sample manifest JSON file. So we'll see that the manifests have a schema version. They'll talk about all the different media types for the different pieces of what you're actually pulling down when you pull down an image. The digests are really important to check the integrity of the pieces that you are pulling down. And then you might have some annotations that are added by the registry, which can be for a variety of different things that are not the most relevant here. And so when we get to okay, but what is a pull now? So the definition from Docker may actually be a little bit surprising. A pull is defined as up to 2 GET requests on a registry manifest URL. So in practice, this will look like v2 slash something slash manifest slash like the image name. A normal image pull will just make a single GET request on that manifest and then read that manifest and go fetch all the blobs that it needs to get and do all the stuff and then run your container. But it gets more complicated than that because a pull request or a pull for for a multi-arch image will actually make 2 manifest requests. So this second star here on this URL template that we see, it may reference a tag like latest, but it also may reference the manifest by digest. So it'll just be a SHA-256 digest at the end. And for these multi-arch images, you may need to fetch both of them. Notably, head requests are not counted. So this is good because if you have a system that's pulling to check for updates all the time, it's not going to increase the pull count. But this is basically the definition that we are working with. And so when Docker maybe starts rate limiting your pulls, if you're pulling down too much anonymously, this is what they're using to measure what actually is a pull. So if you can just fetch blobs all day, you're never going to increment that pull count. You can just fetch manifests and never blobs, and you will be increasing that count over and over and over. And so to just get real into the weeds on what's actually happening here under the hood, so in this call diagram, we've got client and we've got the registry. And they'll basically hit the, most clients will hit v2 to basically ask the registry, are you v2 compatible? And the registry will say yes. And you're authenticated. You then will do a head request on the manifest to check that there is indeed a manifest where you think there is or where the user has told you there is. And then the manifest will say, yes, indeed, there is a manifest here. And then the client will then actually perform the GET request to fetch the manifest with 1 or 2 requests, depending on what's needed. The client will then read the manifest and then go fetch all the blobs. And then, yeah, so again, a name here is organization / image name, and then the reference is either going to be that tag, like latest, or this digest, like a SHA-256 in that digest. So this is kind of a slightly simplified call or when you're logged in, this is the basic call diagram for how a pull actually happens. You'll see it's pretty complicated. There's a lot of back and forth just to download one request, or just to download one container. And so when we talk about what it means to measure a pull, it's not the most straightforward thing. A pull spans multiple API calls. And so if you wanted to just run through the logs and compute the number of pulls that happened, you have to have a stateful event processor. You cannot just go and count the number of occurrences of something. It's not that simple. You also have this kind of distinction of a normal image pull versus an abnormal one. Sometimes we're gonna fetch it once, sometimes we're gonna fetch it twice, and we kind of have to figure out what the right thing is. Then we obviously have kind of the difficulty of sometimes we actually do care about a blob pull, but other times we don't. But really, we're just deciding that manifests are kind of the thing that we're going to measure. And then lastly, different container clients have different behavior. And this is one of those things that I think for registry maintainers and the people building these things causes a lot of headaches and makes this actually really challenging in practice. So, in theory, clients will call head to check for the manifest at the version they need, and they only call get when they need an update. And they'll only do it once or twice if they need to. In practice, many clients are just going to call get no matter what. And that's something that like is just an unfortunate way of the world. There's a lot of people scripting against container registries just directly from Go. You'll have like older versions of a ton of different clients that will not do head at all. They'll just do get every time. They'll never like even if it's cache, they're just going for gets. And so for things like Watchtower, this is extremely problematic because they may be checking the registry like every couple minutes. And if they're old versions, they are boosting your numbers and kind of giving you a false sense of traction. And it gets even worse than that. Some clients will actually fetch the manifest twice. Not because they need to, but because it's an optimization that the maintainers made. And so for Cryo, for instance, Cryo today is going to fetch all your manifests twice. We opened up, one of the engineers, Scarf, opened up an issue about it, and they basically told us, like, this is an optimization that we made. We're not going to change it. And so if you're wanting to count pulls, you actually have to know the client and like count the stuff correctly. It's hard. It's very messy. But despite all that messiness, like there's a lot of data in these pulls. And a lot of it is just totally exposable to the registry. The registry for every poll will see a lot of headers that have a bunch of information, and they just see kind of the time series of these requests, and you can infer quite a bit from that. So let's talk about the headers. If you were inspecting the web traffic to a container registry, you'd see a variety of headers. You'd probably see a request ID, you'd see like the actual IP address of the client. You would see, assuming the person was logged in, or not even logged in, just actually had checked with the registry first, you'll see a bearer token, which is for authorization, and also is included even if you're pulling down without an account anonymously, you will still fetch a bearer token. All these accepts are just for the different content types of the different pieces of the container that you're pulling down. And then very informatively, a user agent. That user agent will have, it may have things like this is telling us this client is Docker. Here's the version of Docker. That version of Docker was built using this version of Go, using this commit on this system, on this architecture with this upstream client. That's a lot of information in that header. And so the registry the registry sees all of this data. But what can we actually learn from this? So one of the really crucial things is this actually gives us a notion of uniqueness. If a user downloads a container today and then one tomorrow, you can actually start to correlate that if you have this notion of uniqueness. IP requests, IP addresses also have a lot of information in them. They can tell you where the user was. If they're on a corporate network, it can tell you what company that network belongs to. If it's a cloud, if it's on like an EC2 instance, it can tell you that it's on Amazon versus GCP versus something else. We also will know the container runtime, which many people won't care about, but some might, because it can tell you about the context that the application is running in. The fact that we see this as Docker here, it's unlikely to be running in Kubernetes, especially now that Kubernetes has kind of sunsetted Docker as the main container runtime in favor of Containerd. And similarly for platform, like it may tell you like, if this is on Windows, this is probably on someone's laptop, and that's really informative to know. Yeah, and so kind of just like to summarize, the kind of questions that you might be able to ask of just the headers alone. I had 1,000 downloads today, but how many actually unique users were behind that traffic? Wanting to know where are users distributed geographically? Like, should I translate my README into French or to Mandarin, or like what should I translate my README to next? Like, that's a very concrete question. If you are distributing containers at a business, you might be definitely interested in which other companies are relying on it. And, for your stats, like, is it CI? Is it not CI? How much can I trust these numbers? And like, what clouds are in play? Yeah, and so like for platform, it can tell you quite a bit about the context that it's running in. If you're running in production, how accurate those numbers are, and also, sorry, was there a question? No, okay. Feel free to jump in though. It's totally welcome. Yeah, knowing kind of the breakdown of the operating systems that are running your container can also tell you a lot about if it's being kind of more run for personal use or for commercial use or for something else. You may have a lot of surprises in your data if you are able to get at the number of uniques behind your traffic. And a really great example of this can be seen on the blog of an organization called linuxserver.io. They do a lot of, they repackage a lot of software and make them all available in one place as Docker containers. And they found out once they had this information that for some of their containers, almost the vast majority of their polls are actually coming from a very small group of people. And so if you were trying to make decisions based on the traffic to your containers, you might get a very, very wrong impression of how many people are actually impacted by changes you make, or maybe make poor business decisions based on traffic that you didn't realize was actually artificially inflated for some reason. And so they saw, when they started measuring this, they saw, oh yeah, WireGuard, interestingly, is actually not used by that many people, but it's being pulled a lot. And almost half of their pulls through Scarf's platform could be attributed to 20 users, and that's very, very informative if you're trying to get an understanding of the usage of your containers that you're distributing publicly. Yeah, I linked to the blog post. It's a very interesting read. I'd highly recommend checking it out. But you may not see this in other cases, but without the information, you're just kind of making a guess in terms of what that total download count actually means. Yeah, so what else can the registry see? I think one of the most important things in here actually is the time series information. So if we were looking at an example of just kind of the request logs to the registry, we might see a single source of traffic that first calls head and fetches, or they first call head and then they immediately fetch the latest version of an image. And then every 5 minutes, they check in again to see if there's been any updates with this head request. So what does that tell us? This can give us clues about the behavior of this user. It can tell us about invocations versus downloads of the container potentially as well. And so, sorry, this is the same example. That was a slightly weird transition. But so for the same example of someone calling head, then get, and then steady, reliable head requests, these intervals are highly regular. It's really likely they're just polling for the latest version. And so if we're going to try to explain that behavior, this is probably a deployment of some kind. It may be a production deployment of the container. It might be internal tooling. But this is probably not someone's laptop if this is happening for a very long time. That's fundamentally useful to know if you're trying to understand the usage of your software. Let's look at another example. We see a head request, an immediate get, then they check for updates twice, 9 minutes later, and then again, and then the next day we see head and get on a different version, and then they go back to the old version of latest. So the relevant info here, these intervals are very irregular. They're fetching multiple versions and then switching between them. And so if we were going to try to guess what's going on here, this is probably just someone developing locally against your container. Could be other things, but that's the most likely explanation for what's going on here. Yeah, and so overall, you can actually get a lot of information about how the software is getting used just from looking at the download patterns. We haven't instrumented any analytics into the code. We haven't added any analytics hooks. All we've done is look at logs that are already out there. Docker Hub has these logs today, GitHub Container Registry has these logs today. If you are distributing containers, someone has this data, but not you. And that's kind of an unfortunate state of affairs. So how can you, the maintainer, the container publisher, get at this data? One way is you can ask the registry to give it to you. If you try this, I'd be very keen to know how it goes. There's many examples on GitHub of people asking Docker Hub and other registries for this information, and not a lot of engagement with these posts from the companies behind these registries, unfortunately. So this issue, which was opened on, I'm realizing I didn't actually show the repo name here. My apologies. This was off the top of my head, I'm forgetting the name of the registry, but this is a Docker repository for like Docker Hub feedback. A lot of support on this ticket, not a lot of engagement from Docker itself, and this is still open almost 5 years later. But try requesting it from your registry. They really should be giving you this information as the maintainer, but so far not a lot of movement from them on this. The other way you can get this data is you can host your own registry. Instead of pointing users to Docker pull an image, they can say Docker pull yourdomain.com/your-image. On the pro side, there's open source solutions for this. So you can pull down the distribution project, a CNCF project, spin it up in your infrastructure. You can start distributing containers from your own domain, and you have full access to everything, these logs included. But unfortunately, if you're serving containers in production, your containers are probably, tens or hundreds of megabytes or gigabytes, and that bandwidth is expensive. And it's also the case that the availability and performance of that registry is like totally on you. So if you spin up, a distribution instance in US West 2 or 1, how long is it realistically going to take you to stream a whole container to someone who's, in India? The answer is it takes a long time. We know. And so that's a huge challenge for actually standing up your own registry in practice. I think for some use cases, it's really great. If you're trying to make like a production grade container registry out of it, like you have a lot of infrastructure challenges to figure out that are totally outside of what distribution will actually do for you. How do you make that fast around the world? How do you make sure it's available and redundant and reliable for your users? It's not easy, and the code only gets you so far. The other idea, which is a bit more novel that we'll get into a bit more here, is the idea of a registry gateway. So the idea is that in between your end user and the registry, so this might be like Docker Hub or any registry, put a gateway service in between them. And so the idea is that gateway is just going to transparently redirect that traffic or proxy that traffic to the registry itself. And then you can spit all the access logs from that traffic, and then you can go process it in the background and spit out all these insights. It's still the exact same thing from your user's perspective. Like you're going to, instead of giving them Docker pull your image, they're going to start pulling it from one of your domains, the domain of this gateway. And as far as the user is concerned, you've basically stood up your own registry. But in fact, they're actually pulling it from the same place they've been pulling, but via your gateway. This has a lot, a lot of pros and cons here too. On the pro side, you can access all the request data the registry can, so there's no loss of information to you. It can be a very lightweight service. You can pretty much just redirect. Rather than proxying means you have minimal overhead on the pull, minimal bandwidth on your servers, and it can still be very performant. And there's an asterisk there that we'll get into later. The nice thing is that you can also, you don't really have to care about the API behind you. You're just passing that traffic. It doesn't really matter what it is. It also will decouple you from the registry. Because, in this diagram, if I want to add a new registry here, like say I switch or I add multiple, the end user doesn't even have to see that complexity. They're still just going to the gateway. So you can still distribute on your own domain. And this approach even works for things besides containers. You can, you could do this to a Python library, to a file like a tarball, or, whatever. This is a very general approach. No plan is without some drawbacks. And so the added complexity here is definitely a drawback of this. So, here we've added a new failure point. If the gateway goes down, suddenly this part, this first arrow is now broken. Sure, they can still go to the same registry that they were going to before, but like that gateway is a breaking point. That gateway is a breaking point. It's also a performance choke point. If that gateway for whatever reason starts to really lag, then like suddenly it looks like the registry is slow, and actually it is not. But a lot of pros on this side to this approach. When I said it was simple, so like you can simply redirect to the registry and you're done. You could simply write this nginx config. You're just gonna, you're gonna take some domain, you're gonna listen on some port, and you're just gonna rewrite all the traffic that comes to your domain and put, registry-1.docker.io, and that's gonna just rewrite all the traffic and send it over to Docker Hub, and you're done. Except it's not quite that simple, because one, the gateway still needs to be fast globally, and if you just stand this up in one place, you have not succeeded in that. And then unfortunately, you actually can't always redirect if you want your container to be available to everyone. Let's get into why. So in the standard authentication flow, so if you say you grab a completely new laptop, you install Docker on it for the first time, and you say Docker pull hello world. The first thing that it's going to do is it's going to check with the registry. Hey, registry, do you support v2? And am I logged in? It's going to say, no, you're not logged in. You need to authenticate. Here are some details about what you need to do. You need to go to this other auth service at this token endpoint. You need to auth for a specific service, meaning the registry, and you need to also request specific permissions. Then the client goes to that auth service to grab that token. The auth service responds with that token, and then you proceed as normal with your new bearer token that you got from the auth service, which keep in mind here is different from the registry. It's a different URL, could be a totally separate service. In practice, that's not always the case, but it doesn't matter a whole lot, I guess, for these purposes. So that's the normal flow. If you stick a gateway in front of it, every time you make a request, it goes to the gateway. The gateway responds with 302 with that redirect, like, hey, you actually need to go to this registry. So you do this dance with the gateway, and then you go to the registry, and then you go back to the gateway and the registry. And unfortunately, with this auth flow, when we start introducing redirects, some clients mess up the token request, unfortunately. They make some assumptions about what the URL of service address is with respect to redirect target. It doesn't juggle those values properly. They didn't account for this redirect. This behavior has already been patched in Containerd. It works in Docker, but also only for certain registries. And so the matrix of where this works and what doesn't, it gets a little bit complicated. But overall, the thing is sometimes you just can't do a redirect. And so you have to proxy in those cases. And so I won't get into this too much, but we at Scarf built a service that basically handles this. And kind of juggles this complexity and sits in between the container, the container runtime clients and the registries that sit behind it, and kind of do this dance of proxying when you need to and redirecting when you can. But I'm going to get into how this registry was actually built. This approach, there's a lot of benefits to this approach, but as we've seen, building it is not trivial. You can't just kind of stupidly redirect, spit out logs, and call it a day. And so we are going to open source Scarf Gateway fairly soon, so I won't talk too much about Scarf Gateway itself as a product, but I'll more get into how it's built if you wanted to go build something like this yourself. And then I'll be sure to link to the open source code of this when we have it. And so the phase one of how we built this, which is what I would recommend to you if you wanted to go out and build your own registry gateway, is you can still use nginx for a lot of this, where you basically are in general just kind of redirecting to this, but you can, and you send your access logs to just any kind of log storage. So we were using AWS CloudWatch for this, but there's dozens and dozens of solutions for how you can get the logs out. And then you can use Lua for a lot of that business logic glue if you need to make sure you are redirecting and proxying the right clients. we were having to like read configs out of Redis because clients may want to kind of dynamically change what registry they're on, and so we had some business logic right there. But once Nginx spits out just these raw logs, you can just go process them asynchronously, and you can spit out whatever insights you want from all that data that we saw. So the headers, the time series information, the tags, all that stuff. We ended up, as we started to kind of productize this a bit, we ended up moving away from this approach, largely because the amount of code that we were putting in Lua was getting more and more unruly. Lua is really great at some things, but I would say its minimalism ends up kind of biting you a little bit if you end up needing a lot from it. And I would say there were just kind of other issues other smaller issues that we ran into, like deploying and those kinds of things. And so what we've moved to implement this is we actually have a handwritten Haskell server, like even to replace like the Nginx level of this. All the configuration is in memory, like loaded at start time and kind of pulled dynamically. Send those access logs off to time series storage like Kafka. And to make it very performant, you can even use the distribution project as a pull-through cache in the cases where you have to proxy. So in a case where you have no choice but to proxy all that traffic to the image, since you now have like 2 hops from the gateway, the client to the gateway to the registry to the gateway to the client, we just cache it and use distribution as a cache for those images and not actually go all the way to the registry. One point that I didn't put in the slides here, but I think is interesting to throw out, is like this is also a way that if you are trying to make sure that your users are not hit by any rate limits that your registry may imbue on your users kind of behind your back, this is a way to get around it. But that's all I'll say about that for now. Obviously, we're collecting data here, and data privacy is paramount to how this is done. However, the high level thing here is that you can do all of this and completely preserve the privacy of your users. Depending on how you store and process this data, like you may have a GDPR footprint. If you're like keeping these raw IP addresses and like doing stuff with them, you're technically processing personally identifiable information, and that has overhead of GDPR. However, I think the recommendations that we would make, having run a service like this, is that you shouldn't touch PII that you don't need, and if you do need it, you should delete it when you're done with it. And so, one of the things that we've been doing is we'll look up IP address metadata about this to see, say, what country is the end user in. And then as soon as you have that metadata, you just delete the IP address from the whole system. And so you're not touching it. No one has it. Everything is a lot cooler that way. And then obviously, if this is something that you don't want to do yourself, you can always have third parties kind of handle this kind of thing for you. There are lots of providers that can kind of handle sensitive data on your behalf, so you don't have to touch it yourself. And then obviously, if you're doing this in a commercial setting, like, you should consult legal counsel. I am not a lawyer. Great. So other benefits of kind of the gateway approach here is that, so as I said before, you can just start distributing containers from your own domain, not someone else's. If you were someone who was distributing on Docker Hub, as of last November, Docker Hub is rate limiting your users, unfortunately, and there's really nothing that those users can do about it except pay Docker money. Do you see any of that money? No. Are they selling, your software essentially without including in that transaction? I would argue yes. I would just make the claim that having more ownership of your distribution channels is a fundamentally good thing for your software and ultimately for your users. It has another really cool effect, is that you can now switch registries on the fly without breaking anything for your users who are pulling from that domain. You can literally publish your containers to all the registries, to Docker, to GitHub, to Google, to all these places, and have the gateway live fail over when a registry goes down. There's a lot of cool, service continuity approaches that you can take when you decouple the registry from the endpoint where the end users are actually going. And there's something very powerful about that if the availability of your service is paramount to users that are using your containers in production. So this gateway approach has a lot of benefits, but there's definite challenges to actually building it. Like, this is overall not a very hard service to build, but scaling it is just as challenging as scaling a lot of other kinds of services. If you want to be available in multiple regions, if you want redundancy within regions and between them, like, that's where the real complexity is here. Like, the code that services these requests is very simple, but orchestrating the infrastructure to actually make this production grade is not easy, and it's unfortunately not that cheap. And it's not that cheap because containers are big and you're going to eat a lot of bandwidth for the amount of times you have to proxy rather than redirect. Overall, you can redirect most of the time, but you still are you will proxy a lot more than you might expect. Go HTTP client is in practice a very common user agent that we see. There's just a lot of clients out there that don't respect the redirects, unfortunately. And like I said, like, there's a lot of different competing runtime and clients, and you end up getting a lot of edge case bugs of how those clients actually hit those APIs in practice. I guess, like, notably, if I go back to like this auth thing, a lot of clients don't do this v2 check, even though Docker says you should. They just skip right to whatever request they're going to do. And so, it begs the question, like, is the v2 thing necessary? I mean, in practice, it's not, but Docker says you should. And there's a lot of assumptions that would be very convenient to make that you actually cannot make as a registry author or as a registry gateway author. And so it's not as simple as this really should be. And this is, potentially one of the reasons why this data is, like, not typically as available as really it ought to be, is because it's actually harder to get it right as a registry than they let on, I think. So I'm kind of, to wrap up here, like, the main points I'm trying to make is that the data that's locked away in that registry that you currently don't have access to as a maintainer is really useful. You can use it to better understand how your software is being used. You can better understand if there are commercial opportunities with your work. Whether using it to just measure the impact of the work that you're doing. The registry has all this data, and they're not providing it to you. It doesn't mean that you're out of options. There are measures that you can take to get at this data, whether it's standing up your own registry, whether it's standing up your own gateway, or using another provider for these things. And so my hope is that I'll kind of inspire more people that you should be getting at this information. It can make your projects better and more successful, and to know that registry gateways, while there's complexity to them, it's a very viable option if getting at this information is useful to you. It's often worth the complexity trade-off. And so that is all I have. Thank you very much. I'm available on all the normal social channels, GitHub, and would also encourage anyone, if this is something of interest, we do provide a free service that does all of this, and that's kind of the end of any amount of sales that I don't want to do here. So thank you very much for listening, and have a great day. I hope to be back tomorrow.
Wait, Avi, do you if you're taking questions, I might have one.
Yeah, please.
Okay. This is Lisa again. Sorry about the
Hi.
kludgy medium I'm using.
No
But anyway, yeah. So I'm just curious, like, in the beginning, when you wrote this program, right? Like, you started this software,
Mhm.
but this is an open
Yes.
source. Okay, but this is an open source project.
So currently, Scarf Gateway is not open source. If you wanted to build your own naive version, like, here's the source code for it. But I think, as I was saying, I think to stand up this service is very easy, but to scale it and actually make it available in production is a lot harder to do. However, the actual meat of this, as Scarf is running it, is going to be open sourced. We're basically getting through this rewrite here, of getting from phase 1 into phase 2, and so a lot of the code is in flux. So we're going to open source it once it's, like, settled a little bit, and then we'll put it out there. Yeah, I think from an open source perspective, there's a lot of opportunities to engage the community on this in terms of, um, even from making Docker and container gateways more hardened to all the different complexity and different clients, but then also to all the other languages and package types out there for people to add their own for like, we're coming out with Python soon, but like, Java and Ruby and all these other ones, like this gateway approach is very flexible and very powerful. Yeah.
Okay. So did you start the I'm just kind of curious because I haven't been familiar with a project like this before. Did you start this because, out of a hobby project because you were having this pain point and you were like, I really want this information. Let me write something that's going to help me get it?
Yeah, yeah. So the story here is that I guess now, like 4 or 5 years ago, excuse me, I had some developer tools that I had written like in my spare time for my day job. Open source some of these tools, and the projects took off to some degree, enough that my nights and weekends were gone fixing bugs from people who were opening them at like Adobe. Um, Enough that I, was thinking like, I feel like I can build a business around these tools, but I don't really know if I don't know that for sure. And I didn't have the data to like actually figure out if that was a reasonable thing for me to do. Um, and so I tried a lot of things and I ran into a lot of difficulties. And so Scarf, like kind of as it has turned, like Scarf as it has turned into, is the evolution of kind of my side projects to address this observability issue in package and container distribution. And Scarf today is basically a company being built around that, and we basically try to help open source projects get a better understanding of their software's usage and connect, especially to connect with the companies that rely on their work, so that they can build sustainable projects, build sustainable businesses around those projects, and just be more successful, whatever that means to them.
Yeah. It's really cool. I can imagine you getting, a lot of holiday and Valentine's Day cards and people just saying thank you for building this. This is really helping me a lot.
Yeah, and so we already have. I mean, I'm weary of giving any too much of a product pitch here, but there are CNCF projects that are distributing their containers on Scarf Gateway today. Linkerd, for instance, all of their containers are going through their own domain, which cr.l5d.io. That's actually pointed at Scarf Gateway. We're the ones behind all of that.
Oh,
A
cool.
handful of
I
other
love the
ones.
Linkerd community. I work with the
They're
Buoyant team
excellent.
all the
Yeah,
time. Yeah,
they're
I
excellent.
just Catherine, they're all such good people. Oh, that's really cool. Okay.
Yeah, yeah. And so we, for CNCF project maintainers, the data from Scarf Gateway is eventually going to be integrated into LFX Insights dashboards. It is a very slow moving process, unfortunately, but it will eventually be an integration there. So you can kind of view Scarf stats in all the like Linux Foundation dashboards that they offer for member projects, which also extends to CNCF projects too. Yeah.
Right on. I just
Product
realized
pitch
I'm
over.
coincidentally wearing my CNCF track chair
Oh,
hoodie,
very good.
which
Very
I
good.
didn't wear in LA because it was way too warm, but I'm wearing it now in Northern California. I didn't do that on purpose. I usually wear like a GitHub t-shirt or something really geeky. John, did you have any questions? I thought this was really interesting. I actually pulled over so I could see the slides. It was actually really fun.
I'm so glad to hear.
Yeah, this is a little bit. I mean, it's always like you already mentioned the issue of you are dealing with personally identifiable information, and this is, I think, stuff that people don't realize that they're putting out there. I mean, is there a flip side to I obviously you're not doing anything nefarious. It's useful. It's helping people understand the value of their product.
Right.
But is there a way that you kind of, as a user, can restrict access to what you're putting out there? I'm always wondering about my digital footprint, right? Or is this the sort of stuff that it's going to be out there no matter what, then deal with it?
So we're saying specifically as like an end user of these containers, how you might restrict this?
Yeah.
That's a great question. So I would say a few things I would say. For containers, it's a little bit of a challenge because there's not really a good way to, for instance, add a do not track header to the request that your container client is making to the registry. That's one of those things that I think having more options in I mean, we do have a lot of good options for container registries, but because they're not really exposing this data, it like hasn't really, it hasn't made the need for this. And what's hard about it is even if one client decided, okay, we will start to support this, like all the clients have to implement it for it to actually be useful. So I think, the short answer to the question is not right now. It's unfortunate that as an end user, Docker Hub does not ask for your permission to collect the IP address. And, in fact, it's like it's impossible to fetch a resource on the internet without exposing your IP address to that resource, just kind of the way the internet works. Does that mean they can process that data? Like, no, not necessarily. But if you look at a lot of package registries today, they all use this data. NPM is using it, Docker Hub is using it, like they're all leveraging this IP address data. And so what our thesis, what I would say, what my thesis on this is like this data is out there. If you are using containers in practice, if you're using open source containers in practice, your IP address is on a variety of web services. It's unfortunate that the set of parties that have that information does not include maintainers. They're the one group of people who I am okay, like wholeheartedly encouraged to use that data. I want maintainers to be more informed about their projects. Over time, I think when I think the open source community as a whole has a little bit less of an aversion to this kind of thing and embraces a little bit more, it'll also come with better privacy controls for end users. Of course, you should be able to opt out of some of these things. And so Scarf Gateway, for instance, does respect those kinds of headers when they're given. But the problem is that the clients don't have that functionality. So it's more of a symbolic gesture on our part than a practical one right now. Yeah, I think overall that the need for better privacy controls in open source is going to start with us, having more conversations about where this data lives, how it gets used, and who has access to it. And so I'm hoping that talks like this will spark that conversation a little bit more, because currently the state of the world is the registries have this and no one else, and that's not a good state of affairs, I would say. I could talk about that topic for hours on end, so I will leave it there for now. But if you want to talk about this more, please get in touch with me after. We will talk about it all day.
Right on.
Yeah.
Cool. If anybody else has questions and you're feeling shy and don't want to, jump on the mic, feel free to drop them in the chat. I think, we presented some really interesting stuff, definitely food for thought. And Lisa was nearly attacked by a giant wild turkey, it looks like.
That was insane. I wanted to take a picture, but I didn't want to risk, messing up this Zoom that's barely working on my phone. But it was huge. I mean, I don't live out in the middle of nowhere either. I'm like, Bay Area, California. I was like, what? Sorry.
No worries. Well, I will say, if questions come up, if any of the people watching this later come up, or if questions from people watching this later come up, please don't hesitate to reach out. I'm on all the normal channels and love talking about this stuff, so I'm happy to answer anything.
Yeah, Avi, so you mentioned that your presentation was on GitHub, right? And
correct.
Yeah.
I can.
If you want to just drop a link in the chat for the meetup.
Yes.
You want to send it to me. I will remind everybody that we do record these. This presentation is being recorded, and it'll go up on our YouTube channel. So if you haven't already checked it out and subscribed, go ahead and do that. And then you actually get a notification when we post things. But Avi will go ahead and put the link to the presentation when we get it up on YouTube as well.
Great. Oh, I should actually send the PDF as well. I'll drop this in Meetup too, but I'm just putting it in Zoom so folks have it.
Oh, awesome. Yeah, perfect. Thank you.
Yep. So there's the org file and the PDF, depending on what you prefer. I'd also very much recommend that method of generating slides for any people that like to make talks in their editor. It's nice. Cool.
Right on. Well,
All right.
Awesome, man. Thank you so much. Really interesting talk.
Yeah, thank you for listening, everyone. I really appreciate it.
Yeah, I know we're all zoomed out these days, but thanks for showing up. And we should have it up. We should, if you want to come and revisit the talk should be up in the next week or so on our YouTube channel.
Yeah, thanks so much, Avi, and I will see you, gosh, in Salt Lake City and probably
Yeah.
Valencia, it sounds like.
Very cool. Possibly on the Valencia. I need to confirm that one still. But yeah, great. All right. I guess I will exit for now. Thank you, everyone. I hope to see you at the next one.
Right on. Thanks again, Avi. Thanks, everybody.
Bye.